All right, so today what we're going to do is we're going to continue our look at algebraic terms. Remember that the only thing that makes something algebraic is that it has a what in it? Letter in it, right? Good. And they're terms because you can't just call them numbers anymore because they have letters in them, right? And remember, all terms have exactly how many parts?
3.
Be careful. 4 parts. There you go. Remember, the first part of every term is its what? Sign. Remember, everything from this point forward is now either positive or what? Negative. Good. And so since the sign is the first part of every term, what do you think you always need to do first? The sign. Right? Get in the habit of doing that. Second part of every term is called the what? Coefficient. Excellent. And remember, coefficient is just a fancy word for multiplier. And when you're just talking about a term, the coefficient is always a number. Okay? Because in a term, the coefficient is a number. But remember, for a parentheses, a coefficient can be anything that's in front of it, right? So coefficient doesn't always mean a number. It just means a number when it's a term. It really means a multiplier. Third part is the what? Base, which is simply means the variable. Whatever letter you have, that's the base. And on every base, whether you see one or not, there is an exponent. Good. Now, we're not going to be dealing with those exponents right now. We're going to be talking about something else. But you really need to make sure that you remember all 4 parts of the term, because later we're going to have an entire chapter that deals with exponents. So make sure you go ahead and get it out of your system there. All right. Make sure that you know all 4 parts of the term. If you don't know the 4 parts of a term, I mean, think about it. That's like saying, I can spell anything in the English language, but unless it has a vowel in it. Right? You can't understand the algebraic system if you don't understand how it's written. Okay? And that's usually one of the major problems that students have with algebra, is that they just never learned how to deal with terms. So we know that each part of the term has 4 parts. What we're going to do today is we're going to begin our look at some of the operations. Okay? And specifically what we're going to talk about today is we're going to talk about multiplying a number term times a variable term. Because we've already discussed multiplying number terms times number terms. We did that all over the place when we did the multiplication and division with signs, right? All we had were numbers. We didn't multiply any letters in there. All we did was multiply number terms times other number terms. Well, today what we want to do is build on that knowledge and start multiplying number terms times variable terms. Now, you're still going to have number terms times number terms. What is a number term? A term that doesn't have a letter in it? In other words, just a plain old number. What's a variable term? Any term that has a letter in it, right? So remember the difference. What you're going to do is, when you're multiplying a number term times a variable term, if you know the 4 parts of a term, you already know what to do. The first thing you'll do is determine the sign. Now remember, we're multiplying here. If you're multiplying, if the signs are the same, your answer is always a positive. If the signs are different, your answer is always a negative, right? Remember when you're multiplying terms. Second, you'll multiply, the numbers, which the number in the number in the algebraic term is called the coefficient, and the other one is the number term. So it doesn't matter that one of them is a number term and one of them is a variable term. You can still multiply them. You can multiply anything. And so the numbers, you'll just multiply. So 4 times 2 is still 8, just like you've always multiplied, right? And finally, you'll simply keep the base. Now, none of the ones that we work with in this section are going to have any exponents, so don't worry about the exponent right now. You do need to know that all terms have exponents, but it's just not a focus of what we're dealing with now. Okay? So, that's it. Determine the sign using the sign rules, multiply the numbers, and what do you do with the base?
Keep it.
Keep it. All right? So let's look at some examples of what I mean. Say we have negative 4x times positive 3. And so obviously the dot means what operation? Multiplication. So I'm just going to, and this is a variable term, and this is a what? Number term. So I'm just going to multiply by first determining the what? Sign. So a negative times a, what's the sign here if it doesn't have one? Makes a negative. Then I multiply the numbers. So the number here is 4 times what? Which makes 12. And what do I do with the x? Just keep it. It never changes. In other words, x times nothing just stays x. Now that's nothing, not a 0, right? Okay? So your completed answer is simply negative 12x. Could that get any easier? Yeah. Sorry? Mm-hmm.
So we don't have to know the answer of x?
No, because you can't.
They didn't tell you what.
Yeah, they didn't tell you what x is, so you couldn't know. So that's all you're doing is just multiplying a number times a letter. And nothing changes except maybe the symbolism and the letters. What operation is indicated when you have this right up against that parentheses? Multiplication. Now we still need to look inside and see if there's anything to do. But there's only one term inside. Is there an exponent? No. Is there a coefficient? Yes. Now remember, from now on, those pluses and minuses go with it. So it's so that the coefficient of this parentheses is what? Negative 2. Not just the 2, but what? Negative 2. So we'll start multiplying by first doing the sign. So a negative times another negative becomes a positive. Then we'll multiply the numbers. So 2 times 4 is 8. And what will I do with the base? Keep it. So in other words, when I multiply a number term times a variable term, the answer becomes a variable term. We're basically multiplying that number into the variable term. Right? So negative times a negative becomes a positive. 2 times 4 is 8. And what do I do with the y? Just keep it.
We just ignored that negative in the middle.
That wasn't a negative. That was a parentheses. Yeah, sorry.
Yeah.
It was a parentheses, and I was kind of showing you it was a multiplication up by putting a dot there. Sorry about that. Yeah, there wasn't one.
Would
Now,
there ever be one?
because then it wouldn't mean multiplication anymore. If you had a minus or a plus between it, then you're combining now instead of multiplying, right?
It would be. Wouldn't that be?
Well, the negative would be the coefficient, but you wouldn't multiply. This wouldn't be the coefficient anymore. That negative would be the coefficient.
Okay.
Yeah.
It would be like.
Don't borrow trouble that yet. Hold on. Just worry about what I got out on the board yet, and then we'll think about that when we come to it. Okay. All right. So multiplying terms is not difficult at all, right? What do? Determine then multiply the numbers. And what do you do with the base? Keep it. But you're not always going to be multiplying just one term times something. We need to talk a little bit about parentheses. You know, your favorite thing. And what I'm going to do is I'm going to write something in what's called general or algebraic notation. It's called algebraic. What makes something algebraic? Letters, yeah. It's called algebraic notation because you use only letters to represent things. So what I'm going to do is I'm going to write down a parentheses just with letters. Now don't worry about doing the operation or anything. You just watch what I've written. Let's say that I have this parentheses. Okay? Now, a B and a C are not the same thing, so you couldn't add these two things together. Normally what happens is you're going to have a number term and a letter term under there, and if they're two distinctly different kinds of terms, do you think you could put them together? No, because you can't add apples and oranges, right? You could add apples and apples, but you can't add apples and oranges. Good. Well, you can't add B's and C's either, because they're not the same thing. Is there an exponent? What's the coefficient here? But because I have two distinct terms inside my parentheses, it doesn't mean just to take the A times the B. It also means to take the A times the what? The C. And this is what's called the distributive property.
Is
I
that
wonder when we're gonna get to that.
Well, here we are. Okay? So, basically, that just says that if you have a coefficient in front of a parentheses, or coefficient of a parentheses, means to multiply every term inside.
it's like a rule, right?
By that coefficient. So not just one of the terms, but how many of them? Well, every term. So in this case it was 2, but what if I had 20 terms inside?
20.
All 20 of them. Yeah,
Is it
every one of them. Okay? Now I'm never going to give you one with 20, but you will have some with 3 or 4, maybe even 5, and I'm not sure what I gave you here. So, keep in mind though, all you're doing still is multiplying a number term times a variable term. So the rule for multiplying terms does not change. It's just that you have more terms to multiply with now. Right? So you just take them one at a time. And when you're doing them, take them one at a time in order. So let's see. Say for example, we have negative 6, parentheses, m plus 8. The first thing I want to do is look inside the parentheses. But inside the parentheses, I have an m and I have an 8. Do you think you could add an m to an 8? No, we don't even know what m is, do we? So there's no chance we can multiply it. Add it to something else. If you don't even know what it is, you can't add it to something, right? Is there an exponent? No. Is there a coefficient? What is the coefficient for this parentheses? And that means to take that negative 6 times how many of the things inside? Everything. And since there are 2 terms, how do I know it's 2 terms?
Because it has 2 numbers.
Yeah,
signs.
because there's a sign between them, right? Anytime you see a plus or a minus, you know that's the beginning of a new term. So that's one term, and that's a second term, right? So I'll just multiply in order, following the steps. So first, a negative times a positive becomes a... And 6 times nothing just stays 6. And since I'm multiplying times an m, what am I going to get in my answer? An m. So in other words, anytime you take any number times any letter, all it does is just cram them together. Because literally 6m means 6 times m. You can't really multiply a number times a letter, but you can stick them side by side, right? Okay. Now we've done the m. Now let's do this term. Again, following the same steps. Negative times a what? Positive is a? And 6 times what? 8 times 8 is 48. And that's your answer. You can't do anything else to it because I don't know what m is, right? And I can't subtract these two because this one's an m and that one's a number, and variable terms and number terms cannot be combined. So that's the best you can do. This is your answer right there.
Hold on, how did you get 6? Negative 6?
It was part of my original problem.
You just bring it down.
Negative 6 times m plus 8. Negative times a positive is negative, and 6 times m is just 6m. There was no number in front of there to multiply with this time, was there?
Right,
So it just stays the same. Okay? Then we took negative times that, and 6 times that. Okay? Right, remember, if there's no number there, then you can't change the number you had. Okay? All right. Let's look at some more of these. You're not going to like this one, but tough. You're going to still have to do that. What does it mean every time I say you're not going to like this one? I'm telling you, you will not pass my class if you can't get over your fraction nonsense. Oh, guys.
Why did people create these things?
Fractions?
No, I mean the whole algebra.
Oh, because it makes your life so much easier. It makes your life easier. Okay, look. Start off with the parentheses. Look first inside. But do you think you can combine 12 y's and 15 z's?
No.
No, because y's and z's, you can't combine them. Is there an exponent? Is there a coefficient? What is the coefficient? Negative 4/3. The fraction, right? But it also has the sign in it, right? So negative 4/3. It means I'm going to take negative 4/3 times how many of the things inside? Both things inside, right? And when you're dealing with fractions, well, first of all, we'll just take the sign. So a negative times a, what's the 12? Makes a negative. And when you're dealing with fractions, oftentimes it's a little easier if you'll take them off to the side and then multiply them. If you don't have to. Because remember, what you're doing when you're doing fractions, fraction rules take over. When you're multiplying with fractions, what do you do first?
Make another one.
What? Reduce. Remember, anything that you can reduce, you need to reduce first, right? You've got to break those old habits and always reduce first. Go back and do your fractions. If I need to, I'll put more fractions on your homework so you'll have to learn the rules. You don't know them?
I do know.
Okay, so when I'm multiplying, what do I do first then? Reduce. What will reduce here? They'll both divide by 3, so that gives me a 4 there and a 1 there. Then I just multiply how? Which gives me 16 over 1, which is just plain old 16. What else did this have in it up there?
Y.
So my term is going to have a y in it. Right? When you're multiplying by a number, the only part that can change is the number, right? Now, let's take that times this one. First of all, determine the what? A negative times a positive is a negative. Then I'll take 4/3 off to the side and multiply it times the 15. Before I multiply, I always reduce. 3 and 15 will both divide by 3, and that gives me a 5 and a 1, which gives me 20 over 1 when I multiply straight across. And what's 20 over 1 equal? And it had a letter up there, so what's going to have down here? A z.
That's the answer.
And that's your completed answer. That's all you can do is just do the multiplication. I still can't combine these because you can't combine y's and z's. Right? Okay. Don't forget your fraction rules. Study those fraction rules. If you haven't memorized them by now, then you don't know them. And you need to. Negative 12 times 7m minus 8n plus 6p. Did I change it? No. Oh, there's just more of it, right? Okay? First of all, look inside the parentheses first. I have m's, n's, and p's. Can you add m's, n's, and p's, you think? No. Is there an exponent? No. Is there a coefficient? There you go. So it means take that coefficient times everything inside. How many terms do I have inside? 3, right? There's 1, 2, 3. Good. So I'll take negative 12 times positive 7m first. So negative times a positive is a? 12 times 7 is? 84. And 84 what's? M. There you go. Done with the 7m. Now I'll do this negative 12 times this term. So first the what? Sign. So negative times a negative is a? Positive. 12 times 8 is? 96. 96 what? N's, right? You're multiplying times n's, so they stay n's. Good. Now we'll take this times the last one. Negative times a positive is a negative. 12 times 6 is 72. 72 what? Well, 72p. Don't forget your letter. And that's your answer. Right? So all you're doing is multiplying terms. Let's look at another one. Negative, in front of negative 6h minus 5y. We have a parentheses, so we need to deal with the parentheses. Where do we look first? Inside. But inside I have h's and y's. Do you think you can combine h's and y's? No. Is there an exponent? No. Is there a coefficient? Yes. But this time the coefficient's not a number, it's simply the sign, right? So, but you still multiply with it, but the only thing a sign can change is what? A sign. Can't change anything else. So a negative times this negative is going to turn that into a positive 6h. A negative times this negative 5y turns it into a positive 5y. And that's your answer. So remember, a negative can't do anything but change a sign. If you don't have a number, then the number can't change, right? What if there were 10 terms inside with a negative in front?
You do them all.
It would just change the sign of every one of them, right? Negative times a negative would become a, and a negative times a positive would become a negative. Okay? How does it look? All right. Now, here is my warning to you. We've got one more section to cover next Tuesday. Then we'll be ready for our first test next Thursday. We'll test up upstairs in the lab. Okay, so hopefully there's no class up there first because we'll have to find out. But I'm going to find out. But there's never been anybody when we go up there early, so I bet there's nobody in there. So what we'll do is next Thursday we won't even come here. We'll just go straight to the lab. You'll take your test on the computer just like your homework is. Your test problems will come straight from the homework. That way you'll have consistency. I will focus on the fractions. If it was possible, every single problem you do on that test would have fractions on it. Now that's probably not possible for me to get everything in there, but let me tell you right now that if I have the choice between a problem with a fraction and one without one, what am I going to choose? From this point forward, I'm talking about next chapter, the chapter after that, and the chapter after that. So you need to get to work on those fraction rules. If you memorize those fraction rules, you won't have that discomfort anymore, right? It doesn't matter what you've done in your past. This is now, right? So dump all the crap about being scared of fractions or never having learned them before, because now you have good, strong rules for fractions, right? Come to the office. I'll work with you as much as you need to. We'll do every fraction in the world. I don't care if it takes it, but you've got to get over that hurdle. Because if you don't, you're never going to be able to progress to when the fractions become algebraic. Right? If you can't do 1/2 and 2/3, then you don't have a prayer when it's 4x squared minus 3x plus 2 with something on top of that. Right? So you've got to really understand how they work. And it's not hard. And I understand that you've built up a resistance to it. I bet you 90% of Americans would rather do anything than deal with fractions. But it's your job now because you're a college student. So get over it. All right.
I have a question. Is that a multiply clause?
The test?
Mm-hmm.
No.
Can you try it like on the homework?